Ladies and gentlemen, another power supply, another 6-year-old power supply at least, another customer return. This is going to be a bit more of a challenge. Voltage drops under load. Let's get that out of its filthy box. More explanations on the inside. As I say, voltage drops under load, 10 volts. So I'm not going to do a short circuit test on this. I'm going to be brave. I'm just going to plug it straight into mains. So I assume there's no shorts in it. $13.9. Okay. Drops into load. Let's give it a load. One small load coming up. I've got the meter hooked up to the output as well. Safety glasses. Oh dear. Where'd you get the 10 volts from? Can you hear that struggling? That's going to be a challenge. So the load I've got there, let's use the proper SI units for it. It's called one light bulb. It's about 1.8 amps. At first glance, there's nothing obvious wrong here. There's nothing blown. There's a surprising lack of corrosion compared to the last few that I did. Had transistors with rotten legs, etc. So there's nothing more to do from this side. As a famous Australian said, let's take it apart. Nothing wrong at first feel. There's a couple of poor solder joints, such as that. A little bit of dust. While I'm looking for possible culprits here, I'm thinking that these are the main switching transistors. Maybe it's only one of those that's getting a signal. Otherwise, two little transistors here, which are supplied from the TL494 chip. So I can measure voltage on the chip, see if it's giving any sort of output, but the multimeter doesn't work very well looking at base signals. I really need an oscilloscope for this, but I haven't got one. So I'll try and make it do with what I've got. Let's check the base again. So it's on AC volts. Not showing anything there. Let's do this one without shaking and touching the screw. Okay. So it's showing 1.1 volts on one base, but nothing on the other. Just wondering if this one isn't getting a signal. Yes, that's what I wanted to do, wasn't it? Was to check the back of the 8-pin chip here. Let's check pin 8. 3.3 volts. The other one was pin 11. Checking the two outputs for the base driver. Okay, so I'm getting voltage on both there. Check VCC while we're at it. Ooh, 28 volts. Previous one I checked had only been on about 11. I'm going to see if I can measure the emitter pins of the base drive transistors. There's two of them side by side. See previous videos. wet fart. So, where's the emitters? Do this without shorting anything again. Let's go from that pin. 3.7. 3.8. Okay. Seem to be getting it at the transistors, and it's going to drive transformer, and then through a resistor each to the bases. I'll do a quick check across the transformer primary. Yeah, it's off and de-energized. That can be seen. Yeah, that's fine. A high Q, full of green lights. Transformer primary is okay. If it was short, it would go all lights off. I've checked all of these diodes and resistors in this little bank. They appear to be okay in circuit, but some of the diodes seem to be passing current in both directions. They seem to be doing that on my other boards as well. This one is giving me different values as well. Like on this one, it's like 0.128 forward volt drop. And on my board I'm working on at the moment, it's about 0.56. So something strange going on. It's one of those problems where I probably need an oscilloscope, but I haven't got one. Not yet, anyway. I'm going to check the AC across the capacitors under no load. It's DC volts. Try not to slip now. 143. 140. That's sharing a 240 volt load. Let's put a load on it. That's one unholy mess of wires. I've got my meter in the background measuring the output voltage, and hopefully I can measure the voltage across the capacitors on the yellow meter. Hopefully my variac can supply enough current to power up one bulb. I think it's got 1 amp fuse in there into the primary. Should give about 4 amps on the secondary. That'll be about 1.5 to 2. Let's find out. Try and measure that before it blows up. 107, 103, so they're balanced anyway. I also need to check on the values of all the resistors and diodes on the other side of the board compared to my known working board. Check the values. This could also be the worst of all kind of fault finding. Something that breaks down under load, which you would ordinarily measure and test out okay. I'm going to test on the chip again under load. I haven't tried this under load, it's only the caps. But I'll see if the outputs to the transistors remain the same, or whether that breaks down. It may be the chip itself that's breaking down under load. Let's turn it on. I'm just going to say it's not even lighting up a bulb. Look at that, it's pathetic. Okay, where are we? Pin 8. It's 1.5 volts under load. And 9, 10, 11, I'll measure it there. 1.5 volts, so it's still outputting. Just occurred to me one thing I haven't checked under load. That's the transformer. Where's the primary? No slippages now, please. Try not to touch any of the pins. 27 watts. 23 volts AC. Huh. To think about that. Let me try that transformer test unloaded by the bulbs. Just for comparison. There we go, 270. So is it that primary side or secondary side causing me trouble? Time for some component tests. Let's do an ESR check on the capacitors, and I've shorted them out, they're fully discharged. And 0 deletes. Let's try that one. 0.27, a bit high. It's making proper contact, is it? Let's try forcing the pins in. 0.28. What's it supposed to be? 470 on day and 251, 0.3. Okay, those are within tolerance. Let's look for something else. Now that I've tested everything on board and compared it to a known good board, everything seems to be within tolerance and in good health. So further things to do would be to directly replace the chip. I'll leave that till last if needs be. I could take off these bulk capacitors and check them out of circuit. I've tested them all ESR, they're in good health, supposedly. There's this, I think it's a polyester capacitor or something similar, it's a big brown one behind. I could take that one off and test it out of circuit. It's got a few things to try before I give up. We're getting serious now, we're ripping things out of the board. Main bulk capacitors, check both, they appear to be fine. I took them out because one of them seemed to be really loose. I thought that the pins were broken or something, but no. I've been testing as well with my cheapy nasty transistor tester. This works fine, except that it times out after about 3 seconds and there's nothing I can do to change it, but it's an additional tool. The other two caps I took out to the secondary side and tested fine. I'm going to rip that one out as well, see if we can test that one. I've tested this little fella. It gives me a value of 971 nanofarad, which is close to 1 microfarad. New day, same problem. I will find this fucker even if it kills me, unless this lockdown bug kills me first. And I've got a board full of spare parts that says I will succeed. I'll just swap everything out. The common choke coil, I've checked that for inductance. It measures the same as my motherboard. And I can't get any sort of readings from these large inductors. It's an unknown part according to my tester. It's a piece of crap. Next to be replaced, rectifier. Next. What about the transformer, sunshine? Even though my coil tester says it's working okay, it's worth a shot. On all of the other boards I've had trouble with, the problem seems to be in this area. Just one little thing here got my attention. I don't know if I've been too rough with this, but there doesn't seem to be a track under there. But I'll bridge it with a pin above it. Be the same thing. New switching transistors in. This may be nothing, it may be everything. I was thinking about the transformers and I thought they were making this noise. These two smaller transformers. Oops, I'm going handheld here. Hold on. There's little pips on there, both on the primary side. Now on my parts board, I've got one on the primary side and the other one is on the secondary side. I wonder, see there's seems to be a blob of solder between two pins there on the IC. This may be another wild goose chase, dead end kind of thing. So I've got the little transformer out, 5 pin one side, 3 pin the other, and I can barely see just about that this pin seems to be shorted out with that pin. There's where the windings come onto the pin, they wrapped it round and it's carried on going and it's touching that one. Would that cause it? For the first time in a couple of days, I've got my hopes up. See if this goes full power. Full power now, blow my variac fuse. Oh, bastard's still fizzing. I replaced transformer 2. Won't make a difference, I suppose. Let's try it. Nope. So it's not that one. Next on the list, day 3, Judgment Day. Can you see what's happening here? Yes, I went for it. Something's buzzing. So I assume it's the transformers. Substitute transformer. See if we made a change for the better or for the worse. Activate. Still fizzing. And the new NTC thermistor. It looks like we're going to have to change everything. See this big resistor here, current sensor resistor, I believe. I was checking a couple of diodes on this. I think it's secondary, no, I think it's the primary side. There's one diode hiding behind the cap here. There's no getting away from it. This chip has to come out. No change. Always say next. Next! You can see how it's going. It's going to be the very last component that I check, isn't it? Or replace. Swine! I'm going to remove the main filter caps. It's that fizzing noise that gets me. I think I'm part way through my donor board already. Next, since we swapped 2 transformers, may as well make it 3. Next in the firing line, I've only got 3 transistors left on the board. It's Q3, Q4, and there's a fan one at the end. I can't believe that will make a difference. I'll replace those. It's the last 3 transistors replaced. It's the last of the semiconductors. Test. Ah! Oh! Hold on, no fizzing. It's fizzing, but we have lights. We have a steady 13.9 volts. Let's apply one bulb. Oops. Some insulation is a bit close to the bulb. Oh, and it's dropped to, it's dropped to 11.5. So it's an improvement, not fully repaired, but it's an improvement. Ah, it's my variax dropped 177 volts. Let me try and bump that up a bit. That's where the squealing noise comes in when these are under voltage. When it was in 200 volts. That's it. 243 volts in. And a steady 13.9 on the outputs under 1 amp load. You're a genius. Only took 12 hours to find it. And all because it was one of those transistors. Because I took 3 out, I don't know which one it is. But they all tested fine in circuit. Hey, I deserve a panad now. I'll try the same on house mains. 13.9. No fizzing. It's been a long time coming. Let's try. .9. It's about 1.5 amp. Let's try another bulb. That should be about 3.5 amps. Voltage stable 13.9. Now we have to wait for something else to go wrong. Isn't hindsight a wonderful thing? I should have gone to the transistors first, shouldn't I? Show you what failed. It's one of those base drive transistors. We've seen better. That one. The other one I replaced was for the fan control. I don't believe that had anything to do with it, but I replaced it anyway. Just one of those 3. Now it's enough for most people to know what failed, and that's it. It's fixed. But I want to check the transistors I took out of circuit. The first one to check is the fan control transistor. That's an S8050. You've got to be quick to see this, because it cuts out after about 2 seconds. NPN EBC. That showed fine. Let's try the others. This next one is Q3. 2N. No, sorry. 2N2222. Again, be quick. NPN EBC. And the last one, this one was Q4. Made it all dark now. Again, 2N2222 NPN. Better show a failure. Ah, it's going to be known or unknown part now, isn't it? Ah ha ha! See that? That didn't read as a transistor, did it? What the hell? I'll have to freeze that, but yeah. So this little bugger, 12 hours of work. Little shit. And if I didn't show it previously, they're the ones I replaced them with. Assembled, here's all the parts that I removed, just to find this one. So 3 transformers, 2 bulk caps, 1 NTC, 3 small transistors, 2 large ones, 3 resistors, 1 diode, and the IC. If I had an oscilloscope, I would have found that within an hour probably, but I had to make do with what we had, or what I had. Not we, there's only me here. Would I consider doing this for a living? Only if I wanted to work for 3 pence an hour, and if that's been excruciatingly painful for you, or useful in any way, feel free, give me a thumbs up, and remember the kebab.